Welcome again to another edition of the Southwest Climate Podcast. I'm here as always with Mike. Mike, how you doing today?
Hey, Zach, I'm doing all right. Happy water year.
3-day weekend.
Loving it.
You look a little worse for the wear.
I need 40 days.
The last time that we came at you guys, we recapped the monsoon. This version is...
Go even farther back in time, because that makes sense. Yes.
We will go farther back in time.
We will.
But first, we'll get you caught up to what's happened since then to now, and then we'll do a recap of the water year in review, the hydrologic water year in review, yet another calendar. This is the October through September period, which aligns better with the hydrology of the West.
No water year cards at the Hallmark store. Tried for you.
That's not all that surprising, Mike. Who knows about the water? Who knows about the hydrologic?
What a missed market, I say.
And of course, we'll look forward a little bit. Talk about the now official La Niña that will be with us for at least the next couple months and
torment us once again over the winter season.
We'll get you guys caught up to speed on La Niña conditions and what we might think about for our winter. This is the time of year, October and November, which can be quite variable. Mm-hmm. And it has been relatively boring so far this year.
I think we have to, I was just asking you, were you here in October? Okay, I give you boring.
I missed,
for sure.
I missed 2 weeks.
Yeah. You get out of town just like something that everybody doesn't know, and you leave town before it gets miserable here.
But this is a high variability time, right?
It's a high variability time, right?
So you can either get these events that come in decaying tropical storms, or these northwestward sort of transition season lows that come in from the Pacific Northwest, or neither.
Yeah.
And so what we've had in October, well, actually in November. So we've had one event in November so far, right?
We actually had two similar events. One early in October. There was a kind of a very weak transition type storm system that spawned some thunderstorms just to the southeast of Tucson in early October. I think it was on October 8th or 9th. I mean, they were very isolated hail-producing storms that emerged off of a pretty weak wiggle low-pressure system. That's a technical term. It's just a wiggle. Wiggle. And it spawned a couple of very, very narrow, very small, but high-intensity thunderstorms that actually dumped accumulating amounts of hail in Safford. I saw some pictures come back where they actually had to get the snow plows out and plow the roads because they had accumulating hail, and it beat up quite a bit of the cotton crop that was still in the fields in early October. Not monsoon. Even the Storm Prediction Center had, I think they may have even issued a severe thunderstorm watch based on the potential for these to become supercell type storms, meaning there's lots of good shear in the atmosphere, change in wind speed and direction with height. So they were moving from the southwest to northeast. Again, pretty small. None of them, I don't believe any were in the sort of Tucson area. So confined to Cochise and Graham and Greeley County. And just happened to strike some of the more populated areas out there. But again, not monsoon by any means. Sort of, again, like you said, transition type.
Right. And it was fairly isolated though.
Pretty isolated. Yeah.
And so we had that event. Early October.
Yeah. And then it just got hot. I mean, we literally had inverted summer. It felt like late May, early June again, even though it was one of those weird things where it would get to be 98, but the sun would be low in the sky. So you couldn't figure out if you're coming or going. Yeah, you couldn't figure out what season it was.
It's almost like that kind of heat, I think, it doesn't hit you as hard. You don't even sort of...
Speak for yourself, man. I was done. I was done. To me, what I expect is I expect the weather to follow the sun, right? And as those days got shorter and shorter, I wanted some respite, but maybe
I don't spend enough time out during the middle of the day to experience the 98.
I do. I don't know. I mean, this is walking from one building to the next, but it got to be old. I mean, and this is interesting too. If you look at the temperature traces from the beginning of the month to the end of the month, what you normally see is, you lose about, I don't know, a quarter of a degree today, a day, maybe a little bit less than that. So you're going from maybe a daily average high of 75 at the beginning of the month to 70, 65, 70 by the end of the month. What we actually saw was the temperatures actually increased through the end of the month. So by the last week of October, we actually had highs that were record highs, and they were up in the mid to upper 90s. So it actually got warmer through the month, which is very confusing as the days are getting shorter. Each subsequent day is getting warmer. So
do we know where October fell in terms of its ranks?
Some locations it was the warmest in 120 years of record keeping. You see that with the National Climatic Data Center, also known as National Centers for Environmental Information. I have not kept up on my acronym
Changing
translator.
acronyms.
Yeah, I need to have a little guidebook on the acronym transitions. But every place was in like the top 10 percentile,
Which,
the top handful of years.
I mean, that's kind of a similar story for recent years.
You know, it was definitely a strong ridge, but it's definitely part of the trend. It's definitely the climate change signal come home. No pure attribution in either direction, but you know, everything working together in concert. It stood out as very unusual. And then over the last, for the 2 weeks of November that we've had so far, it's still been pretty warm. You know, we haven't really had that crash with a really strong cold front coming through yet. And what we actually had early in the month was a fairly unusual, not terribly unusual for the Southwest, but you don't see it every year, was one of those cutoff low pressure systems that actually did a double loop on us. As it did that, it spawned a pretty widespread thunderstorm event with lightning and hail, technically grapple, big globby snowflakes that melt on the way down, so they come off. You know, if you've ever seen that, you know, it's like a chunky piece of ice that if you kind of smush it in your hands, it feels like a snowball.
It's like a snow cone.
It's like a snow cone. Hail has striations through it. You know, it's that getting lifted up and sort of cycling through a storm.
October was, in fact, the third warmest in the history for Arizona as a whole. Yep.
That's pretty good.
And it was
definitely up there.
It was the warmest since 2003 for
That's
October.
Right, yep.
The record was set in 2003. The temperature anomaly was 5.3 degrees Fahrenheit.
Yowza.
That's pretty substantial.
That is pretty substantial, yeah.
Yeah, so that is part of the warming trend that we've experienced, although that is obviously an anomaly that can't be attributed to the trend in and of itself. I mean,
no, it's not pure attribution there. No.
There's the ridging, as you said.
It was a strong ridge. I mean, what we had, if you looked at the weather pattern through much of October, is you had a very strong low pressure system, the Aleutian Low in the Gulf of Alaska.
It just sat there.
It did, and you watched it. You have little low pressure systems that would migrate around the sort of center of action of the low, and it would actually retrograde. You know, so it would wobble forward and then it would wobble back. And the fact that it wasn't, the whole sort of wave train of the jet stream wasn't progressing, is that you just had a static ridge.
Yeah. So why was it not progressing? Like, why wasn't it moving through?
I don't know.
But now's the time when you start seeing.
Yeah, I think storm systems can get a little bit blocky as you're sort of transitioning into the season. There's a lot of stuff going on upstream. There was some typhoon. You know, you get these sort of late season typhoons that
you're always chasing your tail. In other words,
exactly.
Right?
Yeah,
it just always goes backwards.
Yeah, totally. I mean, we go all the way back across the Pacific Ocean. You can get these typhoons that they'll make landfall in the sort of far West Pacific, or they'll get entrained into the westerly flow, and that energy from the typhoons gets absorbed in the jet stream, and then can induce or sort of reinforce the waves in the jet stream that are already existing, or, you know, some downstream. There was other stuff too. There was some blocking going on upstream in Siberia. There's a fairly complex but static weather pattern. And as we move forward, that will evolve more into a wintertime pattern, and I'd expect us to see some transition type stuff, more sort of wintry type stuff coming up fairly soon.
So as a whole, October was dry. I mean, it
did. I mean,
it came in as below average across the entire state. In fact, if you look at like a west-wide map, there's this diagonal that goes from basically central California all the way up to the northern border, northeast border of Montana. That sort of above that, north of that was above average, and below and south of that was below average.
You can trace the jet stream right through that breakpoint between the Pacific Northwest. I think the Pacific Northwest had its wettest, you talk about Seattle, had its wettest October on record, right? And the fall, October, November is their wettest time of year. They got been
slammed.
And they've done this for a couple years in a row now too. They've had these exceptionally wet sort of shoulder seasons of falls and springs. I think it really shows, you know, getting the record heat down here, record wet up there, points to having a very stagnant
and the ridge building would help funnel all the western storms up in that area.
Yeah, I mean, those little rotating low pressure systems around the anchored Aleutian Low, they got a parade of storms through there. The precip amounts were pretty epic.
Okay, hot and dry.
Hot and dry down here, yeah.
Yeah, hot and dry down here.
Yeah, and again, so on our precip side too, you and I've talked about this, but the bar is artificially high here for October precip because of a couple of historic wet events. The distribution down here is like a lot of zeros.
Median would be a better way to look at this.
Yeah, probably. Like looking at a percent of normal map it's gonna be red. It's gonna be dry more years than not, just because October doesn't typically do much unless we get something epic that comes through.
Right, and those are dominated by the recurving sort of decaying tropical storms from
the big
the Pacific.
Ones. Yep, the big ones in the past, and even we
easier to be dry. Harder to be wet.
Yeah.
But the averages more reflect the wet, or those big years sort of bring up the averages.
Right. Yeah. We do the tails of the distribution better in October than you do in most months. You can get to both sides of it. That's a pretty wonky way of saying it, I think.
Let's take a moment here and think about the water year in review. So let's sort of recast the October 2015.
Go all the way back.
We're gonna do 1 year.
Oh, man.
Yeah, so I am going to make you relive the heinous
Do you remember how much
event.
promise, how giddy we were back in October 2015?
You know what? I actually don't want to do this segment.
What was it? I know. See?
I don't want to make you relive that.
No, I'm sorry. No. We'll do it. I'll be fine.
And the reason we do this is because this helps us put drought into context.
Yeah, it gives us some context for what we should expect out of the climate down here.
And it incorporates both seasons because we have a bimodal precipitation here. We have the winter, we have the summer, looking at them together. Sort of sometimes they can even out, sometimes they reinforce each other. When you look at the sort of October to September period, most of Arizona was basically around normal. The southwestern quarter of the state, the sort of Phoenix to Yuma, and even actually if you go over into Southern California was dry, running below 90% of average, and in some locations actually below 60% of average. Most of the other parts of the state were right around average. As you go up into Utah, it got above average, and even like the Upper Colorado River Basin probably was just right around average. So by and large, the accumulation of both last year's winter, the El Nino that wasn't, at least for part of us, as well as this relatively decent monsoon season sort of even each other out.
Right. I think that's probably the big story that we'll try to pick apart over the next couple of minutes. You go back over that 12-month period over the water year and things wash out towards average, but it's anything but average in the way that we got there in most of those locations, right? Which you can argue that in any given year, but this was I think a fairly unusual path we took to get to September 30th.
Yeah, so let me just rattle off these 12 months. Starting in October for Arizona in particular, actually for both Arizona and New Mexico, and large swaths of the West, aside from sort of California, was wet, above average. So boom, we had a nice kickoff to the hydrologic year. November sort of tanked. Well, the Mogollon Rim area experienced some precipitation.
They did. They picked up a glimmer of hope with actually a little bit of accumulating snow early on in the season in November. For the low country and for the lower elevation stations across Southwest, it was fairly quiet.
We were closing in on the apex of the optimism.
I'm going to sprinkle a little color commentary as we go through these months. So October, Tucson picked up almost 2 inches of rain by the end of October with 6-7 events. So a couple of those were over 3/4 of an inch, right? One of the first events was a tropical storm. It was a named storm that became post-tropical, did some stuff. We also had some sort of, sloppy monsoon leftover stuff in that month. But yeah, by the end of the month, it's not El Nino-driven precip, but we'll take it sort of idea, and the best was yet to come, right?
And then that best didn't show up in November.
No, October, we were at the apex of the optimism, not seeing much of that El Nino pattern really sort of showing up, but we had talked ourselves into, or I had convinced you that
I wasn't
the
convinced.
Best was.
I just want to go on the record and say that I was
know
not
you
convinced.
weren't. You were. Yes. You were more sober about this than I was the whole way along. Yeah. I was arguing. Well, November's not a solid ENSO month, anyways. So the center of action is still coming up.
Okay, so below average in November. Fast forward to December. Again,
December was
deal.
terrible. It was. I remember. December was terrible. December was very dry, relatively cool, a couple of really good cold snaps that kind of rolled through there. By the end of the month, New Mexico had actually picked up a snowstorm on the sort of east side and had gotten hammered with that. I was very jealous sort of looking east there.
You know, and I do remember the chatter was like, don't worry, it's going to come. The atmosphere is going to respond.
Yeah. And then it was all the
epic
talk
El
of
Nino event.
Well, it's not the fall anyways, right? We should be looking at January, February, March.
Boom, January happens.
That's right.
And this
El Nino comes home right after New Year's.
Okay, I'm going to do the next couple months and
you just
combined.
You're going to jump forward because it's easy.
So February, March, I'm looking at this red map and it's almost like they slaughtered an elk down here. I mean, it is just flat red.
Crazy. Yeah.
And by that, I mean less than 5% of average.
Inverted spring. The temperatures jumped to the equivalent of late April temperatures in early February. Now, I'm not being hyperbolic here. They literally were the temperatures in early February were the equivalent of the normal daily average highs of late April for Tucson. And this is across the Southwest. Pretty
much all of the West, aside from like the far Pacific Northwest, was dry. Now, March actually had a different story. Again, it was the bullseye was on Arizona, New Mexico, and parts of Southern California. But north of our region, it was quite wet. This marks the fact that the jet stream was just slightly further north.
Yeah, it's actually starts to look more like a fairly normal transition into spring type pattern, where a little bit even north of the upper Colorado River Basin starts to get precip.
Well, and the crazy thing is I remember the talk here was like, this looks a lot like a La Niña pattern.
It did. Totally
I mean,
like
it does.
La Niña pattern. Yeah. Yes, it did.
So then April's we don't get a lot of precipitation in April.
No, this was the second year in a row where we started to see this kind of weather that we would typically see in February and March show up in April and May. And I think it was largely attributable to an El Nino type response sort of showing up in the late spring. We had in the sort of the misfire of the El Nino the previous year, we had something very similar. And what you and I were talking about before we started here was like the Miracle May in the upper Colorado, which they actually started to get accumulating snow and some lower elevation precip in April and May. Happened again this year. I do think was sort of El Nino leftovers in the spring.
May, it's hard looking at these maps that have percent of average.
Yeah, at that point, a
small accumulation can cause it to look very wet.
But the fact that it rained at all. That's saying something. And, the pattern across the Southwest was that some places actually did pick up significant amounts of precip in May. Parts didn't, which aren't too surprising. The temperature, though, May ended up being very close to average, which in this sort of long-term trend felt cool, which was kind of unusual because we'd expect it to be pretty warm.
And we don't necessarily need to go over all the details of the monsoon because we had just covered that in the most recent podcast. But the monsoon started early. June was, I believe the first rain that we got here in Tucson was around June 20th. And we had a fairly decent accumulation in June, and that rolled right into early July as well. I remember July being fairly good, but most of Arizona looks like experienced drier conditions during July.
Yeah, July was the weird month where we had that long break right in the middle. Right after the 4th of July, we had a big slowdown. Southeast Arizona actually picked up some more precip. New Mexico was quite miserable. They had very little activity for most of July. So July was quite a bit slower, except for a couple of locations than we would have expected to see at the first month of monsoon. It wasn't until we got into August we started to see more of that widespread activity, which we talked about in that podcast.
And August turned out to be pretty good for both Arizona and New Mexico.
Again, there's always little spots that end up falling behind just based on the nature of the precip.
Again, that takes us to sort of a near average water year for much of the Southwest.
You want to talk about September?
Did I miss September?
You just skipped it. There's not much to talk about.
I just skipped over September.
There's only, really, honestly, Tropical Storm Newton.
Well, see, I was gone.
That's right. So it doesn't even count in your mind, does it?
No,
people live here, man. We were here. We suffered through it. It was that boosted some water year precip totals quite significantly based on one day. Tropical Storm Newton almost made it into the U.S. as a tropical storm, but was called just south of the border that its wind speeds and its circulation had fallen apart and wasn't going to be. So it became post Tropical Storm Newton as it crossed in the U.S. Was a very widespread in the sense of all of southeast Arizona, parts of southwest New Mexico.
Southern California as well.
Yeah, a little bit Southern California, a little bit different residual moisture kind of coming up for that. The core of the circulation, though, went right up through southeast Arizona up into New Mexico. Long duration, 24-hour event, anywhere from 1 to 4 inches of precip for some locations. And so coming at the end of the water year, of consequence to that total.
Right.
We transitioned out of the monsoon quite inauspiciously.
One of the stories here in the Southwest is the water supply. And the Colorado River Basin during the water year experienced slightly below average flows. So one of the major stories here, in at least in terms of the water year, is looking at sort of its effect on the water supply. And upper Colorado River Basin experienced flows about 90% of average, which sort of perpetually is taking us closer and closer to that, shortage declaration on Colorado River. We can talk about that. If not on this podcast, we should probably spend a little bit more time talking about that. But by and large, across New Mexico, reservoirs declined by about 10%, whereas Arizona, the reservoirs remained more or less what they were when they started the season. So, water supply it's never in a good state here in the Southwest. It hasn't been for more than a decade now, and the El Nino that we had hoped, at least many water managers had hoped, didn't deliver, and so we're going into the upcoming winter and really a worse case situation, at least in New Mexico, than we were last year. Just for people paying attention, Elephant Butte Reservoir is still around 6% full, and again, many people there in the lower New Mexico depend on that for irrigation. Water, right. Colorado River. The most recent forecast for the shortage declaration pins it at a likely January 2018. So again, we still seem to be pushing this slightly down the road. It's still not a question of if, it's sort of a question of when. Although we've been in the last 3 years sort of thinking it's more imminent than perhaps it is. And if La Niña throws us a curveball, at least in Colorado, delivers above average precipitation, could be even further down the road.
Yeah, you and I were trying to do the thought exercise of what has been the weather that's been able to allow us to kick the can down the road a little bit more. And the pattern of precip the last couple of years has not been stellar for sort of early, solid accumulation of snowpack. Is it, you were just kind of musing here, is it the Miracle May effects of these sort of late spring accumulations in the upper basin that just cut the time for when the stream flows drop off in the summer? I don't know. Is it the timing of the precip? As you're saying, though, the stream flows have been at 90% of average. So they've been below average. They've
been below average, and we're also running at a structural deficit. So
yeah. And
each
I don't know
year, we should be drawing out more and coming closer to that iconic 1075, which, it's right now the water levels are at 1,078 feet above sea level. What triggers a shortage declaration is the forecast made in August for the upcoming January. And if that forecast for the water levels in Lake Mead is below 1075, then it triggers the measures that they have agreed upon to reduce it's basically CAP, Central Arizona Project, draws less water than they were allocated. The projection for this upcoming January is not below 1075. I think it's 1080. And the 50% chance for January 2018 is for it to be below 1075. But of course, things could change by what goes on this winter.
Right. We've learned nothing about trying to predict the future, clearly, in our sort of discussion here.
Things are sort of on the sort of severe level in terms of water supply, and that's not going to change until we get successive years of substantial winter rains.
We're going to pivot at some point here into the outlooks for this winter, but I don't know.
It's likely not going to be this. It's likely not going to be this winter.
I like that.
There's still a chance that it could be. I think that's one of the lessons that we've learned from recent events, including the El Nino.
Yes.
Why don't we just talk very briefly about the hurricane season? I'd say there's a couple stories to the last year, and I think the Eastern Pacific has been above average. So that we've experienced, I think, 21 named storms in the Eastern Pacific Ocean, 6 major hurricanes. Mm-hmm. Both of those, I believe the average is something like 14 named storms and 3 major hurricanes. A major hurricane is category 4 and 5, or is it category 3, 4, and 5?
I think it's 3, 4, and 5.
Yeah, 3, 4, and 5.
Yeah. I think largely what the research is pointing to, and what we sort of know qualitatively with the Sea-specific hurricane seasons, is that a lot of this was the El Nino driven, and the pattern of the sea surface temperatures and some of the corresponding atmospheric patterns too had really driven this recent activity over these last couple of years. So our sort of super mega hyper El Nino of the last 2 years really did create a favorable environment for really active East Pacific storm seasons. Given that and this sort of transition away from that, I'd expect to see like next fall be quite a bit quieter across much of the basin there.
So average, let me correct some numbers that I said before, but
you fact checking?
Yeah, I'm fact checking right now. I mean, I think this is a really good function that we can do here. It's real time fact checks. Let's hold ourselves accountable. We should hold ourselves accountable.
Charge ourselves for that service. Then I think that's good. Yes.
So the 1981 to 2010 average is 15.5 named storms, 7.5 hurricanes, and 3.2 major hurricanes. You were pretty close. Yeah, what we experienced, I was pretty close. Yeah. What we experienced was 21 named storms, 13 hurricanes. So
pretty good, huh?
Pretty much double.
Double it.
Close to double. And double the major hurricanes at 6. So it's
busy.
Yeah, it's been very, very busy. We also had the other thing that you didn't mention, or if you did, I wasn't listening. I was too busy fact checking. It was the earliest on record, the earliest in the year tropical storm, right? I believe it was.
Yep.
What was that? That was Polly. Yeah. That's right. Category 2.
Yes.
The Atlantic Ocean also had a fairly active, although not as active, but the damage was much larger over there in terms of dollars just because of Matthew. We've sort of alluded to what's up in store for us. And I think recently it's become official after some waffling whether or not this La Niña event would take shape.
Yeah.
It has taken shape. The measurements are in place. The metrics are in place. People expect that a weakish La Niña will take form or will remain in form through the early parts of this winter.
It's been a very interesting and humbling seasonal forecasting set of years here. And, as we went into the El Nino and tried to figure out what El Nino was doing in real time and tried to track its strength and magnitude and then saw it sort of rear up and then not deliver us the sort of teleconnections and the patterns we wanted to see, in the Southwest or expected to see. I was clearly wish casting for that that wet winter down here.
Mike's wish cast. You have a model for that?
I do have my wish casting. It's a very simple model.
What is your wish cast for this year?
My wish cast is for I'd like to see some cool weather, pleasant weather coming up, and then I'd like to see some precipitation. I'd like to see some snow and snowpack across the Southwest. Wouldn't that be fantastic?
Massive snowpack would be great.
Massive snowpack. Some good mix of some rainy days, some sunny days in there.
So basically your wish cast is always for the wetter side of things.
Oh, absolutely. Yeah, absolutely. Yeah. How many days a year do we spend here staring at blue sky? Beautiful. I don't want to knock it too much, but I thought that was our one chance to sort of see what an epic El Nino was going to do. But anyways, the point being was that we were in the spring looking towards what would happen with the evolution of this El Nino. And 1998 came up as a potential analog. Again, that second largest magnitude El Nino with a very rapid crash to a very strong La Niña event, which really did set up some of the conditions we saw in the drought conditions of the late 90s and early 2000s. This event didn't do that. It kind of waffled a bit. It slowed down. It hung out in El Nino. Forecast models then started, any month now it's going to crash to La Niña. And we had a couple of about faces, didn't we, early in the fall, where there was a forecast. Yeah, there was a forecast, and then they backed off. Climate Prediction Center backed off of the forecast and said we're now heading for neutral.
And the atmosphere just wasn't playing along, and that's been the story.
Yeah, it was exactly what we had going into the El Nino. Was the atmosphere was lagging, not cooperating with the ocean. Same thing was happening early in the fall, where the La Niña signal had emerged in the sea surface temperature pattern. The atmosphere was sort of shrugging, which I was in favor of, right? I was in favor of it sort of ignoring the ocean and going back towards, let's just go towards a normal winter here. There's now more organization, more of a signal in the atmosphere, but the models really don't point to this to being a sort of a deep, long, dragged out, strong La Niña that persists deep into the spring. Most of them show it sort of crashing midwinter towards neutral. But does that really matter? I don't know. I'm not sure it's going to matter or not.
Yeah, so let's get to that for in a second. But if you look at all the models, the statistical and dynamical models, like there's only one that has it reaching sort of a moderate strength.
Yeah.
Most of them having it between neutral and a weak La Niña.
Yeah. And like reaching its peak magnitude like right about now.
That's right. Most of the peaks are around the November, December, January. So we're right on the edge of it.
But should we believe them?
I think if we use last year's El Nino, right, they got the forecast for El Nino.
Yeah.
Right. It was much harder to then forecast the teleconnections to that.
Fair enough. Yeah. It did. Okay. It did. Right. But it was basically a nowcast. It was adjusting itself. It every month and every subsequent update was following the evolution of the monitoring. We'll have to go back and sort of think about it. Maybe I'm just so bitter now that I don't believe that there was ever a good forecasting signal in there.
Well, and for us, like, who cares like what the tropical Pacific Ocean temperatures are like, right? It's all about like what the
it's about what the
weather is going to happen.
Right.
Yeah. So I mean, it's almost sort of like a secondary.
Yeah. But we
the science got it right, but but they missed the forecast for the precip.
The forecast really missed the nuance of it was a flavor of El Nino that we didn't have in the historical record. And the historical record was short. If we had 1,000 years of El Nino, how many of those El Ninos would we have seen? Probably more than zero that we had in our back pocket. So what does a La Nina mean for the Southwest? La Ninas for the Southwest are pretty reliably dry.
Yeah, they are. And in fact, if you look at the events that fell between neutral and La Nina, like most of those, the total accumulated precipitation for those seasons are all hovering around similar numbers.
Similar numbers, right.
It's only when you get out to a weak El Nino and above does the spread sort of increase. That being said, the neutral years have had the wettest year on record.
Yeah.
Excuse me, not year. Winter.
Yeah, winter on record with 1993.
1993. Yeah. Coming in for the southeast Arizona area, Climate Division 7, so southeast Arizona, for the December through January period came in at close to 11 inches.
Yeah, it was pretty epic. It was either one or multiple, so what we call these atmospheric river events, which are these sort of focused, funneled, subtropical moisture type storms trailing across the Southwest. It's interesting, if you look at 1993, 92, 93, December and January, all of the weather happened in December and January. Nothing before it, not really much after that and into the spring. So, I mean, it stands out as a pretty unusual year in the historical record.
So to your point earlier, the numbers that we have definitely suggest that we have much greater chances of coming in at a drier winter.
We do. And so, again, this is where you have to think about the region as a whole. And so the signal is typically, talking about La Nina winters, it's typically stronger further south. So like the southern half of Arizona and New Mexico, La Ninas tend to steer that storm track further north. So you can have situations where the northern part of the state has less of a risk than the southern part of the state. So you see that in the official forecast coming out from Climate Prediction Center.
Yeah, and that's a good point, I think, for our conversation earlier about the reservoirs.
The basin, too.
In the basin, because there isn't as strong of a signal for the upper Colorado River.
That's right. So
go snow,
man. And this is too.
I'm rooting for snow.
I am too. We could just use it every once in a while. I'm not trying to be greedy here. Can't you say like once every 5 or 10 years we get a good year out of this climate system?
Go 1993.
Go 93. Yeah, go 93. Well, some people would just assume 93 not happen again. It was an epic flooder across.
You're right. That's bad. That's
much of Arizona.
That's bad karma.
It's bad karma. Don't wish on
1979.
Don't will your Godzillas.
Does anybody remember 1979?
I don't.
These are just numbers.
These are numbers we're pulling out here. But let's maybe one of the. I'm just going to be an optimist here. I'm going to try this out today. Weak La Niñas into the sort of neutral, sort of bridling this line here. Some research suggests that this week, a La Nina to neutral conditions, we can actually have the Madden-Julian oscillation play a much greater role in the subseasonal variability here, right? Because during El Niños, you don't typically have the easterly winds to propagate along these storm systems from across the Pacific Ocean. And during La Niñas, it's too strong to have good propagation. So in this sort of middling zone, you can start to see the subseasonal variability exert itself a little bit more. I don't know. Maybe there's an upside here. Maybe we see some more of these other teleconnections start to play a positive role into the weather systems of the winter. I think what it does say is that we should lean just the pessimistic side and probably bet on dry here, but there could be a couple of surprises. I am sure I said this a year ago, And
we should
was
always bet on
surprised.
dry.
I should, but I was surprised by February and March by brutally hot and dry they were. That was not the surprise I was looking for in that particular year. The surprise I'm looking for this year is a couple of good knockdown, drag out wet events that are nicely timed throughout the spring. It's not too much to ask for.
I think that's a great way to end it.
Okay.
Thanks for that optimism.
You're welcome. You're welcome.
I needed that. Thanks to all of you for tuning into the Southwest Climate Podcast. We'll come back and do the December edition, the holiday edition.
The holiday edition with eggnog. Sort of holiday scene. I don't know. We'll figure it out.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA program manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahon, Research, Outreach, and Assessment Specialist with CLIMAS.
Edit that one out. Please get rid of that.